grade 12. Today we're going on to a new section. This is going to be in book 1, functions and inverse functions. Okay, these are from your PowerPoints. You guys can pause the video at any time and then just copy it into your books. All right, so let's just have a look first what they're saying here. A function is a relationship or a rule between two sets, the domain, which is your x values, and the range, which is your y values, where every element of the domain is associated with one and only one element of the range. Now, basically what that means is for every x value that I have, it'll only have one y value. Then it is a function, okay? And we've got little tricks that we can use to see if it is a function or not. The first one is called a vertical line test, and you can highlight this. And it is used to test for a function. Now, if a vertical line cuts the graph once, the graph is a function. So for example, take your ruler. This is in the vertical direction, that's in the horizontal direction. So we are going to test the vertical line test. And if I put my ruler and have a look where it's cutting this graph, you can see that it's only cutting the graph at one point each time I move it along. That means for every x value that I choose, I'm only getting one y value. That means it is a function. Now, if we have a look at this one over here, if I take my ruler over here, you can see for this x value over here, whatever this x value is over there, we are getting two y values. It is cutting the graph twice. Therefore, this is not a function. And you can see as I go along here, each time it is cutting twice. So that is not a function. And that is how we can test if something is a function or not, by using the vertical line test. There are two types of functions. We have a one-to-one function. Highlight this. Okay, what does that mean? One element of the domain is associated with one element of the range. So for every x value that I choose on my graph, I am only getting one y value. And you can see that over here. If I choose this x value, come up to the graph, go across, I'm getting only one y value. I can do the same over here. Choose an x value over here, go up to my graph, go across to the y-axis, and you can see I'm only getting one y value. Let's go over here. Choose an x value over here, go to the graph, come across to the y-axis, and you're only getting one y value. So one-to-one is if you're getting one x value to one y value. The next one that we get is a many-to-one function. That means many x's to one y value. Many elements of the domain, remember that's your x values, are associated with the same element of the range. In other words, your y value. In other words, more than one x value for a particular y value. First of all, I'm just going to see if this is a function. Get the vertical line and we just go across. And you can see that it's cutting the graph only once. This is a function, but it is a many-to-one function. What does that mean? If I choose this x value over here, come up to the graph and then come across, you see we're getting this y value over here. But if I go with this x value, I come up, go to the graph, come across, we're getting that same y value. So we're getting many x values to one y value. And it doesn't make a difference where I go. I mean, I can choose an x value over here, come to the graph, and then come across. But you can see I can choose exactly the same x value over here, come across, and then go to the graph. You're getting the same y value. So many x's to one y value. So we spoke about a one-to-one and a many-to-one function. Okay, the horizontal line test. Right, this is used to test if a function is one-to-one or many-to-one. If a horizontal line cuts the function once, it is a one-to-one function. So let's highlight that. So if the horizontal line cuts once, it is a one-to-one. First of all, I'm going to test if this is a function. So we use the vertical line. Okay, and as you can see, it's cutting my graph only once. So this is a function. But now I want to see, is it a one-to-one or is it a many-to-one? Take the horizontal now, and you can see that it is only cutting the graph at 1 point. So this is a one-to-one. If we have a look at this one over here, if a horizontal line cuts the function more than once, it is a many-to-one. So more than once, horizontal line test, it is a many-to-one. First of all, I'm going to see if this is a function. So we take the vertical line, and you can see here, it is cutting the graph only once, each time I move it along. Okay, so we know it's a function. But now which type of function? A one-to-one or a many-to-one? Horizontal line, and now you can see that it's cutting the graph at 2 points. There and there, there and there, there and there. So this is a many-to-one function. Okay. Important, the vertical line test must always be used first. That will help you decide, is it a function or not? Okay, once you've decided that it is a function, if this test shows the graph is a function, use the horizontal line test to determine the type of function. And remember, we have two types, a one-to-one and a many-to-one. Okay, so if we have a look at example 1. Example 1 is saying here, consider the following graph and indicate whether the graph is a function or not, and give a reason for your choice. Take the vertical line, and my graph is only going from this point to this point. I'm not going to check outside of that. And as you can see, as I move along the graph, it is only cutting the graph at 1 point. So for A, yes, this is a function. My reason for this is every element of the domain is associated with one and only one element of the range. Now, let me repeat that. For every x value that I'm choosing here, I'm only getting one y value, okay? So we can say here, for every x value, there is only one y value. Okay, that is important. It has to be one y value. Okay, let's have a look at question B. If the graph is a function, which it is, state the type of function and give a reason for your choice. Okay, now remember, we do the horizontal line test now. And as you can see, it's cutting the graph only once at each point. And if it cuts it only at once, it is a one-to-one function. So this is a one-to-one function. And my reason for this is one element of the domain is associated with one element of the range. So one element of the domain is associated with one element of the range. In other words, for every x value that I'm choosing here, I'm only getting one y value. Question C, write down the domain and the range. Now remember, the domain is your x values. X is an element, and as you can see, it's running from -3 up to 3. So -3 up to 3. Now remember, open dot means it's a round bracket, closed dot means it is a square bracket, it's inclusive. Now what we have to do is we have to do the range. Y is an element, start from bottom to top. We're going from -2 to 4. This is inclusive. This one exclusive. And there's our range. Okay, going on to example 2. Consider the following graph and indicate whether the graph is a function or not and give a reason for your choice. So we take the vertical line, and as you can see, it is cutting the graph twice. There. Doesn't make a difference where I go. It's cutting twice. So this is not a function. Okay, now my reason for this is every element of the domain is associated with more than one element of the range. So every element of the domain is associated with more than one element of the range. In other words, we are getting more than one y value. Okay, question B. If the graph is a function, state the type of function and give a reason for your choice. Well, this is not a function, so we can't answer this. Okay, question C. Write down the domain and the range. So the domain is your x values. So we read from left to right. Now, just remember that this is a circle. So if we wanted to work out the radius, it's just the square root of that, which is 6. That means that it's going to sweep around with a radius of 6. So this coordinate would be 6. This one would be -6, -6. So our domain would go from -6 up to 6. And because this graph goes through that point and through that point, we can include both of them. Now, if we look at the range from bottom to top, it's going from -6 to 6. And again, guys, because the graph is going through those points, we can include both of them. Okay. Going on to example 3. Consider the following graph and indicate whether the graph is a function or not and give a reason for your choice. Okay, so vertical line. As you can see, it's cutting the graph at one point each time I sweep it across. This is a function. My reason for this, every element of the domain is associated with one and only one element of the range. In other words, only one y value for every x value. Okay, question B. If the graph is a function, state the type of function and give a reason for your choice. Well, it is a function. So now I do the horizontal test, and as you can see, it's cutting the graph twice. So this is a many to one. This is a many to one function. Okay, my reason for this is many elements of the domain are associated with the same element of the range. Okay. Question C, write down the domain and the range. So our domain Okay, now, because this graph continues on both sides like this, and it's going to expand as it goes on, that means that we can have any x value because it'll just get wider and wider and wider as it goes along. So here we can have any x value. In other words, x is an element of the reals. Then the range, we read from bottom to top. So this is going down to minus infinity up to 7. And because that goes through our point, our graph goes through that point, we can include that one. And then infinity, we cannot include. And there's the range. Okay, going on to example 4. Consider the following graph and indicate whether the graph is a function or not and give a reason for your choice. So we do the vertical line. And because this is a hyperbola, just remember that we have asymptotes, guys. The graph does not go through the asymptote. So over here, it's cutting once. Then we skip this asymptote, and then we go to our next arm. And you can see that it's cutting the graph once. And because it's cutting it once, it is a function. The reason for this, every element of the domain is assigned to one and only one element of the range. Question B. If the graph is a function, state the type of function and give a reason for your choice. Do the horizontal. Start down here and you can see that it is cutting the graph only once as I move along there. We skip this value because that's an asymptote, go to the next arm, and you can see there it's cutting only once. So this is a one-to-one function. My reason for this is one element of the domain is associated with one element of the range. Okay, question C. Write down the domain and the range. Now, because I've only got two values here that it can't be. For example, it can't be when x is equal to 2, and the other one is when y is equal to 3. And it can be any other value, okay? So for the domain, I'm just going to say x is an element of the reals, but x cannot be equal to 2. Similar for the range. Y is an element of the reals, but y cannot be equal to 3. And we just exclude those two values. Okay, grade 12s, what you can do for me is exercise 2.1, numbers 1, 2, and 4. Thanks, guys.